All right, for the following quadratic x squared plus 3x plus 9 equals 0, I'm going to first find the discriminant so I know how many real solutions I have. Then I'm going to determine, based on my discriminant, how many solutions do I have, and then I'm going to solve it regardless of whether it's the real solutions or complex numbers, I'm still going to solve. So the first thing I'm going to do is make sure everything's on the left-hand side. So we have x squared plus 3x plus 9 is equal to 0. I want my quadratic to be equal to 0. Now that I check to make sure we have everything on the left set equal to 0, I'm going to state a, b, and c. So a is equal to 1 because that's the coefficient on the x squared. B is equal to 3 because that's the coefficient of the x. And c is equal to 9. So now that I know a, b, and c, I'm going to use my discriminant equation, which is b squared minus 4ac, or my discriminant expression, to figure out what the discriminant is equal to. So I know b is equal to 3, so I have 3 squared, minus 4, a is equal to 1, c is equal to positive 9. So I'm left with 9 minus 4 times 1 times 9, or 36. 9 minus 36 gives me negative 27. So my discriminant is equal to a negative number. If the discriminant is equal to a negative number, I am left with 0 real solutions. So kind of reviewing what we did last week, if we have a positive number, it's 2 real solutions. If you get 0 for your discriminant, you have 1 real solution. And if you get a negative number, you have no real solutions. So 0 real solutions. So now that I know I have no real solutions, I know I'm going to get a complex number for an answer when I use the quadratic formula. So now I'm going to move forward by using the quadratic formula to actually find those complex number solutions. So move this up a little bit. So my quadratic formula is x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. So as I go through, we have x equals negative b. I know b from the top is equal to 3, so negative 3 plus or minus the square root of. And like we said before, our discriminant, we already found b squared minus 4ac was negative 27. So I'm not going to recalculate that discriminant. All over 2 times a, and we said a was equal to 1. So as we start simplifying, we have x is equal to negative 3 plus or minus. I see that square root of negative 27. I know I need to factor out the I to get rid of the negative. So I have I square roots of positive 27 all over 2. Then I'm going to break down the 27. So 27 broken down with a factor tree, we get 3 times 9. 9 is 3 times 3. I have a pair of 3's. So that gives me x is equal to negative 3 plus or minus 3. There's already an I out there, square root of, and then I have a 3 left over, all over 2. And then we're going to separate the real from the imaginary. So x is equal to negative 3 over 2 plus or minus 3i square root of 3 over 2. So my two solutions are negative 3 over 2 plus 3i root 3 over 2 and negative 3 over 2 minus 3i root 3 over 2.